Hey everyone, Mr. Aaron's. Today we are starting our first day of everyone being distance learning. It's going to be a little bit different, but for these first couple weeks, you're going to pretty much do what you've been doing this whole time. Once we get to the end of the trimester, we'll talk about some changes. But for now, just keep doing what you've been doing. Today we are going to be working on our new chapter as we took our test on Friday. Hopefully it wasn't too tough for you. So today we're going to work on chapter 4. We're getting into factors, fractions, and exponents. Our exponents, we talked about those in PEMDAS, but haven't yet had to deal with them yet. This chapter we'll talk about them a little bit. Today we're going to be talking about divisibility and factors. This is stuff that I think you've probably seen before, stuff you know. It'll be a quick little refresher lesson. We'll get some practice with it, and we'll get you on the road. All right. So when something is divisible, what that means is that two numbers are divisible if they can be divided and have a remainder of 0. What it really is telling us is if when we divide them, they divide out evenly. If they divide into a good number and are decimal or a fraction, then they are divisible. So for example, we have 18 divided by 3. Those two numbers are divisible because they equal 6. There's no decimals, there's no fractions. That checks off, that's good. 18 divided by 4, that doesn't fit in evenly. If it was 16 divided by 4, then yes, that would be a 4. But 18 divided by 4 does not fit in evenly. This would not be divisible. There's a remainder there. They don't fit in evenly. There would be a remainder of 2. Another example real quick. If we did 4 and we divided that by 2, that would go in evenly as 2. That would check off. If we did 4 divided by 3, that's going to be a decimal. That's going to be a fraction. That's not going to work out for us. There's going to be a remainder there. It would be, that wouldn't even be 1. It'd just be a fraction. So numbers that fit in evenly are going to be our divisible numbers. Otherwise, they are not divisible. Okay, here I have some rules for us. These are some helpful rules to figuring out if numbers are divisible once we get to some bigger numbers. And you can't just look at them and know right away. So these are the rules for 2, 5, and 10. So for 2, 5, and 10, integers are divisible by these numbers. For 2, if it ends in 0, 2, 4, 6, or 8. So examples of that would be 10, or 22, or 34, or 46, or 58. See the gist of it here? If it ends in an even number, if that second number is even, then we know it is divisible by 2. All those even numbers, any even number is going to be divisible by 2. It is divisible by 5 if it ends in a 0 or a 5. So we got examples like 20, 35, 65, 100. If that last number is a 5 or a 0, then it's divisible by 5. Things you already knew. And it is divisible by 10 if it ends in a 0. So examples of that would be 20, 660, 70. They end in 0, they're divisible by 10. Easy peasy. Those are our rules. They're pretty simple for those ones. So we're going to look at these examples here, crush through them real quick. It says, is the first number divisible by the second number? We're going to look at this first one. We got 567 by 2. We look at our options, 0, 2, 4, 6, 8. This one ends in a 7. This would not be divisible by 2. No. Second one, 1015 by 5. We look at 5 if it ends in a 0 or a 5. This one ends in a 5. So we already know, yes, that's going to check off. All right, number 3, we got 111,120. We know our rule for divisible by 10. If it ends in a 0, this one ends in a 0. Yes, looking at that 0 right there. Right here, we've got 160 by 5. We got 5 if it ends in 0 or 5. This one ends in a 0. This one would also be a yes. 56 by 10. Let's look at our 10 rule. If it ends in a 0, does 56 end in a 0? No, it does not. That is not divisible. And 53 by 2. 2, 0, 2, 4, 6, 8. This one ends in a 3. That would also be a no. Pretty Pretty simple stuff. Use those rules for any time you're asked if it's divisible by 2, 5, or 10. Follow these rules. I'll change up in the rules. We got rules for 3 and 9. These ones are a little bit different, a little trickier. Integers are divisible by 3 if the sum of the integers are divisible by 3. So what that means is we have to take the numbers that build that number, add them up, and see if it's divisible by 3. So let's check it out. I have right over here, I got 21 equals 2 plus 3, or 2 plus 1, which is 3. 3 is divisible by 3. 3 goes into 3. Checks out. Second one is 9 is the sum. If the sum of the digits are divisible by 9. So we got 81. I do 8 plus 1 equals 9. That's divisible by 9. Checks out. It's a little trickier because you got to add up those sums. It's completely different than the rules for these ones. We'll get some practice with that on the back side here. But we got to add those up and then figure it out from there. So we have, is the first number divisible by the second? 567 by 3. So we're going to start by adding up those sums. 5 plus 6 plus 7 equals, it's going to be 11 plus 7 equals 18. Divide that by 3 equals 6. It's a nice even number. Yes, that is divisible. 18 is divisible by 3. All three of those numbers added up. We do a little plus sign between them all. They add up to 18. Divisible by 3. Yes. 1,015 by 9. So we're going to take 1 plus 0 plus 1 plus 5. And that's going to get us to 1 plus 0 is 1 plus 1 is 2 plus 5 is 7. This is going to be a no. 7 divided by 9 is not going to be a good number. That's going to be a decimal. That's going to be a no. Doesn't fit into 7. 9 does not fit into 7. Number 3, we got 64. So let's do it. 6 plus 4 equals 10. 10 divided by 9 evenly. No, it doesn't. That's not a good number. It doesn't fit in well. But I want to add one in here just for good measure. I'm going to do, let's do 72 by 9. Tossing it at the end. Then we got one chance of 9 there. All right, next one, we got 472 by 3. So we're going to take 4 plus 7 plus 2. That's going to equal 11, 12, 13 divided by 3. That does not work out. 13 divided by 3 doesn't work good. So that one's going to be a no as well. 174 by 3. Let's try it out. 1 plus 7 plus 4. That's going to equal 12 divided by 3. Check. That one works. 12 divided by 3 is 4. It's a nice even number. No decimals there. Awesome. Last one, we got 72 by 9. So let's do 7 plus 2 equals 9. Divided by 9 equals 1. No decimals there. That one is also a yes. So you add up those sums for 3s and 9s. Check if it fits in evenly. If it does, it's divisible. If not, it's not divisible. All right. So that's how you can check those ones. Now we're going to talk about some factors here. Something you probably already heard of. Factors are numbers that can be multiplied to get another number. So basically, if we have a number, anything that's all of its factors are numbers that you would multiply to get there. So for example, our factors of 12 are any numbers that we use to get towards 12. I listed them out right here. I got 1, 2, 3, 4, 6, 12. Those are factors because I paired them up. 1 times 12 equals 12. 2 times 6 equals 12. 3 times 4 equals 12. Those are the 3 ways that we can multiply to get to 12. Those are our factors. 1, 2, 3, 4, 6, and 12. Numbers that can be multiplied to get another number. So if I had my factors of 4, I'm thinking, what can I multiply to get to 4? Well, I can multiply 1 times 4. I can multiply 2 times 2. And that's it. Those are my factors right there. They'd be 1, 2, and 4. All right, we are going to find our factors of 20 using rows. This is a strategy to help you find some factors if you're a little stuck here. So the first thing you do is you start with one row. think that's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Perfect. So this is one row of 20. There's two of our factors, 1 and 20. Next, I'm going to do two rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I know this is going to go in twice as 10. There are two more factors. We got 2 and 10. Now I'm going to try three rows, see if that fits in evenly. So let's go 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And look at that. It's not fitting in evenly. We are missing that gap right there. 3 does not work. Okay, let's try 4. 1, 2, 3, 4. 2, 3, 4. 4. Oh, there's 16, 17, 18, 19, 20. Fits in perfectly. 4 with 5. We got another factor there. I'm going to stop at that. I'm thinking 6. Would 6 divide into 20 evenly? No, it would not. 6 times nothing gets to 20. 7 times nothing gets to 20. 8 times nothing gets to 20. 9 times nothing gets to 20. 10 times 2, we already got to that one, so we're done. Check them all off. These are our factors. I know you can probably do these in your head, but using these rows can be another strategy to help you get through those. All right, real quickly, we're going to list the factors for each. I'm going to cook through them. I'm thinking 10 here. Let's see, we got 1 times 10, 2 times 5, 3 times, nope, 4 times, nope, 5 times, nope, yep, we got 5 times 2, but we already wrote that one. 6, 7, 8, 9, nope, and that's all of them. We're done. Our factors are 1, 2, 5, and 10. 21, let's think it out here. We got 1 times 21. Notice that's almost always going to be a factor. Well, it is always going to be a factor. 1 times itself is always going to be a factor. 2 times, nope. 3, yep, 3 times 7 gets us 21. 4 times, no. 5 times, no. 6 times, no. 7 times, no. 8, 9, nope, 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 nope. We are done. 1, 3, 7, 21. Once you hit that same number twice, you can know you can be done. 3, we got 24. We're going to start with our easy one. 1 times 24. Okay. 2 times what? 2 times 12. That gets 24. 3. Oh, this one works too. 3 times 8. Wow, look at all these. 4. 4 times 6. 5, no. 7, or 6. We already got it. 7, no. 8, we already got it. 9, 10, we're done. We already hit 8 twice. We already hit 6 twice. So we know we're done. We got a bunch for this one. 1, 24, 2, 12, 3, 8, and 4, 6 are all factors. What the? Why do I have 24 on here twice? Forget about that one. All right, now last one is how could we rearrange 33 or 36 kids in rows? This is going to be the same thing. We're counting our factors. I'm going to do this one in my head first. I'm going to go 1 times 36. That works. 2 times, let me think here. 18. That works. 3 times, let's see. 3 times 12. Perfect. 4 times 9. Perfect. 5, no. 6, yeah, 6 times 6. Perfect. 7, no. 8, no. 9, we already got. We hit the same one twice. We know we are done. We could rearrange these in rows of 1 row of 36, 2 rows of 18, 3 rows of 12, 4 rows of 9, or 6 rows of 6. Those are all ways that we could rearrange. All right, here's your 15-minute lesson. Intro to chapter 4. Let's crush these factors and those divisible numbers. A little bit of review today. Good work.